Welcome to the deep dive. Today, we are tackling a topic that just seems to create so much anxiety. We're talking about personal hair dye use and that persistent question, is there a link to cancer?
There is so much conflicting information out there. And our mission today is really to slice through that noise. We've gone through everything. The really dense epidemiological reports from groups like the Cosmetic Ingredient Safety Panel, all the way to consumer assessments and decades of scientific papers.
And we want to give you a clear view of where things actually stand. So let's just get to the bottom line right away. Because if you're worried about your last dye job, the news is pretty reassuring.
It is. The overwhelming scientific consensus right now is that the available data do not provide enough evidence to support a causal link between modern personal hair dye use and cancer.
So there it is, the high-level takeaway.
Yes, the scientific community have been very clear on this for a while now.
But, and this is the big question, if the science is so clear, why do we keep seeing these scary headlines? Why are certain ingredients always getting flagged? That's what we have to unpack. The history of these products and the really nuanced data that's hiding in some of these smaller subgroups of users, that's where all the confusion comes from.
Absolutely.
Okay, so let's start with the basic chemistry. I mean, to understand the risk, we have to know what we're even talking about. What makes a dye permanent?
Right, so permanent dyes are all about a chemical reaction, a pretty complex oxidation reaction, actually. They rely on two main things, what we call primary intermediates. Think of p-phenylenediamine, or PPD, that's the famous one, and then coupling agents like resorcinol.
And these are the things that actually create the color.
Well, they become the color. They have to react with an oxidizer, which is usually just hydrogen peroxide, inside an alkaline environment. That whole reaction is what creates the final big color molecule that gets trapped inside your hair.
And the concern has always been around PPD and those, what are they called, aromatic amines? Why are those the red flags for scientists?
So the reason we worry about aromatic amines is because of how your body metabolizes them, how it breaks them down. The chemicals themselves aren't always the issue, but when your body processes them, they can form these highly reactive compounds that can potentially interact with your DNA.
And that's the cancer link, the potential for DNA damage.
Exactly. That's why PPD is flagged by IRRC for potential risk. It's also why it's just flat out banned in European cosmetics.
And it's not just PPD. What about the other stuff in the box, the couplers, the structural ingredients?
We see flags on those too. Resorcinol, for instance. It's a known skin irritant, a sensitizer, and the EU actually classifies it as an endocrine disruptor. Then you need that alkaline pH, that's usually ammonia, which has its own issues, though many ammonia-free dyes now use something called MEA, monoethanolamine, as a substitute.
But even if you dodge all those, we saw some concerns about preservatives.
Yes. Things like imidazolidinyllurea or DMDM hydantoin. The issue there is that they are known as formaldehyde releasers.
Formaldehyde, that's a known carcinogen.
A known carcinogen and irritant. And then, of course, there's the catch-all ingredient fragrance or parfum. It's almost always undisclosed what's in it, and it's constantly linked to allergic reactions and respiratory issues.
So here's the paradox that I found really fascinating. Even if you read the label and you avoid PPD and all these other things, the chemical reaction itself creates new chemicals, right? Things that aren't on the label at all.
It makes a simple risk assessment from the box almost impossible. You can analyze the starting ingredients, but the final molecule that's locked in your hair and maybe being absorbed by your scalp is chemically different.
That's a huge gap.
It's a massive challenge for regulators, and it's compounded by this really unique regulatory status here in the U.S. These synthetic organic colors, what they call coal tar hair dyes, they're actually exempt from pre-market FDA approval.
Wait, exempt?
Exempt. As long as the manufacturer slaps on a caution statement and instructions for a skin patch test, they don't need prior approval.
And that brings us to maybe the single most important variable in this entire conversation time, the year 1980. The reason the old studies look so scary and the new ones look, well, mostly fine, is because the products themselves fundamentally changed.
Exactly right. Before 1980, hair dye formulas had chemicals that were known potential carcinogens, things like 2,4-diaminoanisole. These were later removed after FDA warnings and a huge industry push to reformulate. So if you're looking at a study that measured someone's exposure in, say, 1970, you're measuring a completely different product than what's on the shelf today.
So the first question you have to ask when you see a headline is, when was this exposure? Was it pre-1980?
Precisely. That cutoff is the key. The FDA's current guidance reflects this. They monitor the research, but they state they have found no reliable evidence that currently marketed dyes cause cancer in people.
Which brings us back to that overall consensus. You see these huge meta-analyses. One of them pulled together 79 studies from 11 countries. And the overall link between personal hair dye use and cancer is just consistently weak, or null. For breast cancer, the pooled risk was something like 1.06.
And that number is so important. A relative risk of 1.06 is statistically so close to 1.0, which means no effect, that you really can't say there's a meaningful general risk there. The evidence just doesn't support it.
But if the overall risk is so low, why are the results from different studies still all over the place? And this, I think, is where the methodology comes in.
It is almost always methodology. The first big problem is confounding factors. People who dye their hair might have other lifestyle habits. The Big Nurses Health Study, for example, noted that hair dye users were more likely to smoke and drink alcohol.
So the dye could just be a stand-in for a whole lifestyle, not the actual cause. And if you don't control for smoking, your results are going to be skewed.
That's spot on. The second major issue is just exposure assessment. Think about how hard that is. You're trying to ask an 80-year-old woman what brand and shade of hair dye she used in 1975. And how often?
It's impossible. It's a huge memory recall problem.
It is. So studies get graded on quality from just a simple, did you ever use it, up to the really high-quality ones that track the dye type, color, how long you use it, frequency. And trying to combine all that messy data makes consistency very, very difficult.
And lastly, a lot of these big foundational studies, like the Nurses Health Study, they were very homogenous. That one was over 96% European ancestry.
Which is a significant limitation.
Right.
It means you can't necessarily generalize those null findings to everyone, which is why the deep dive has to go into those specific subgroups.
Okay, let's do that. Let's look at where the smoke really is, even if the fire isn't proven. Let's start with hematologic cancers, non-Hodgkin lymphoma, NHL.
Here, the historical link is very strong. Multiple studies show a clear increased risk for NHL in women who started using dye before 1980.
Before 1980 again.
Again, especially with dark shades, or if they use it a lot, like over 100 times in their life, the odds ratio for that group was 1.3.
So a 30% increased risk, which is statistically significant. But it's tied entirely to those old formulas.
That's the takeaway. It's the cleanest example of that temporal cutoff. For women who started using dyes in 1980 or later, no increased risk for NHL was found. The industry changes seem to have fixed that specific problem.
Okay. Now for breast cancer. This is where the data gets much more complicated and, frankly, much more concerning for certain groups. Tell us about the sister study.
The sister study is a big one, almost 47,000 women, and it had a really high-quality exposure assessment. And while the overall risk was only up by about 7% in white women, which is pretty small, they found that using permanent dye was associated with a 45% higher breast cancer risk in black women.
45%. That is a massive disparity.
It's a huge, statistically significant finding. And other studies have kind of reinforced this idea that darker shades might be part of the issue. One showed a higher risk for dark shades in African American women and a similar risk for dark shades in European American women.
Which suggests it could be about the concentration of the chemicals, right? Darker dyes need more of those primary intermediates to work.
That's one of the leading hypotheses.
Yeah.
But it also raises questions about biology. And just to clarify one point quickly, for bladder cancer, that risk is pretty consistently shown to be an occupational hazard for hairdressers. People who are around these chemicals all day. For personal use, the studies just don't find a link.
So for the person at home, this brings us to this idea of personalized susceptibility. Why could two people use the exact same box of dye and have totally different outcomes?
And this is where the science gets really fascinating. It comes down to our genes. Specifically, genetic polymorphisms. Think of your body as a little chemical processing plant. You have these enzymes with names like NET2, GSTM1, whose job it is to detoxify the aromatic amines from the dye.
So if my enzymes are really efficient, they neutralize the chemicals before they can do any harm. But what if my body is slow at that job?
That's what's called a slow acetylator phenotype. It's caused by a really common variation in the NAD2 gene. If you're a slow acetylator, your body's filter is sluggish. That means you have a longer exposure to those reactive, intermediate chemicals floating around in your system, which could, theoretically, elevate your risk.
And this might be the biological mechanism that connects back to those racial disparities in the sister study. If certain genetic profiles are more common in some populations, and those profiles are slower at detoxification.
That could potentially explain why the risk appears higher for them, even when they're using the same products. That correlation is exactly what researchers are racing to figure out now. It suggests risk isn't just about the product, it's about the person using it.
And this risk, it's not just about cancer. The more immediate risk is allergic reactions. Contact dermatitis, itching, rashes, these are really common. So for current users, what are the actionable safety steps we can all take?
The safety recommendations are very consistent, and they're all about minimizing exposure. First, the patch test. It is mandatory to do it before every single use.
And I'm going to guess most people don't do that. It feels like the fine print of beauty products.
I know, but you should. Allergies can develop at any time. Second, always wear gloves. Nitrile or latex are best.
What about ventilation? We talked about ammonia and formaldehyde releasers.
Definitely apply the dye in a well-ventilated room. And critically, never apply it to an irritated scalp or right after you've had a perm or a relaxer.
Why is that?
Because those processes make your skin more permeable, so you absorb more of the chemicals. The advice is to wait at least 14 days. And then, when you're done, rinse your scalp really, really thoroughly.
So let's bring it all home. What is the key takeaway for you, the listener? The major scientific consensus is that the hair dye you can buy today is not causally linked to cancer, especially after those big safety changes back around 1980.
Right. We saw a clear case of the industry responding to data and removing the known bad actors from their formulas. But associations do still pop up in specific subgroups, particularly for people using very dark shades and maybe for people with certain genetic profiles. These are areas that definitely warrant more research.
And remember that those inconsistent study results are often just due to really complex methodological problems, confounding factors, and the sheer difficulty of measuring a lifetime of exposure. Which leaves us with a final, provocative thought for you to take away. Given that your own genetics, your NAT2 status, for example, can significantly change how your body processes these ingredients, the future of this research isn't just about what chemicals are in the box, it's about who is using the box. So the question is, if we could one day identify these genetic markers easily, would you want to know your personal risk profile? When you decide to use a common product like this, how do you factor in a risk that is so deeply intertwined with your own unique biology?